Go down and see it. Now, water north of the equator swirls counterclockwise. South of the equator, it swirls clockwise. I'll show you. Here's a video experiment. They put a sink right on top of the equator. This is in Ecuador. Anybody can go down there. They drew a line on the concrete right there behind the person. This is the equator. They're going to pour water in the sink and let it drain on the equator. Now watch. Straight down. Okay. Now let's pick up the sink. Go south of the equator. 15 feet. Plug the sink, fill it with water, let it stabilize a minute.
Ready, guys?
Pull the plug, drop some leaves in. Why does it swirl south of the equator and not swirl on the equator? Called the Coriolis effect, because the Earth is spinning. Now let's take it north of the equator, 15 feet away from the equator. You can Google, I forget the name of this thing, but just Google, does water swirl north or south of the equator? Comes up, there's a bunch of video clips of this kind of stuff. Okay, we're going to fill the sink with water. It's going to swirl the other direction, I promise you. Pull the plug, drop in the leaves, and it swirls counterclockwise north of the equator. Your toilet will do the same thing, maybe. There are other factors involved with the toilet because it's so small. The difference in the speed of the spinning of the Earth over 6 inches may not be great enough to see this. Plus, it may be designed where the water coming out of the tank goes down through the jets and already starts a swirl. If you eliminated all of those factors, it would swirl one way north of the equator and the other way south of the equator. There are things that can influence a small thing like a toilet or a sink, but with still water, it'll do that.